Hello, 8th grade. Today we are going on to 4.2.3 in science, conserving energy. So we are on page 237 in your reading book. Again, we are not doing a lab today, but you will have questions to answer at the end of the chapter. So, conserving energy. Objectives. Identify forms of energy in given systems. Compare renewable and non-renewable resources. Determine methods for conserving energy. Vocabulary. Non-renewable resources. A resource that cannot be replaced once it is used, or can be replaced only over long periods of time. Renewable resource. A resource that is constantly available or that can be replaced in a relatively short period of time. Energy is never really lost. It is simply converted into a different form. To better understand this, think about a roller coaster and the energy required to push it over the ride's many hills. A mechanical device often pushes cars over the first hill, but after that, the cars usually do not get any assistance. Therefore, each hill must be smaller than the previous one. Why? At the top of the first hill, the roller coaster cars have a lot of potential energy. I know you girls have been to Six Flags, so if you're going up the tallest hill, it's like click, 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 click. All of that is potential energy as you're gaining all that energy until you get to the top. And then as you go over the precipice, you are then being converted into kinetic energy and forward movement. So at the top of the first hill, the roller coaster cars have a lot of potential energy. The sum of this energy must carry it through the whole ride. As the cars go up and down the hills, the potential energy converts to kinetic energy and back into potential energy again. Think about our pendulum we were talking about last time. So as it goes down, the kinetic energy is being used. As it goes back up, it's transferring that kinetic energy into potential energy and slowing down until it gets to the top, and then it's transferred back into kinetic energy. If that hill was too high for it to go, eventually that kinetic energy would go into rolling backwards and ending up stopping on the ride. And so the subsequent hills have to be smaller so that it keeps that forward momentum. The cars never return to the same height that they started from because of friction. On the way down the hill, some of the car's potential energy changes to kinetic energy, but some convert into thermal energy from friction. This leaves less kinetic energy to climb the second hill. So the second hill has to be shorter than the first hill. On the way down the second hill, more potential energy becomes thermal energy. The rest changes into kinetic energy that the cars need to climb the third hill. Although none of the original energy is lost, some of the mechanical energy is always converted into thermal energy through friction. The sum of the energy of the entire system, kinetic energy at the bottom of the first hill, sound energy, and thermal energy, equals the amount of the original potential energy at the top of the first hill. If all the energy remained as mechanical energy, the ride could go on forever. But some of the energy is converted into non-useful forms, so the ride must eventually come to an end. According to the laws of conservation of energy, energy cannot be created or destroyed. In physics, when something is conserved, the amount does not change. Although it cannot be created or destroyed, energy can be wasted. Leaving the door open in the wintertime when the furnace is running to keep the house warm or sitting in a long drive-through line is using energy unnecessarily. Taking a longer route than necessary to get somewhere or turning on more lights than needed is using energy inefficiently. Some energy sources, such as solar energy, a type of radiant energy, and wind energy, a type of kinetic energy, constantly replenish. These are renewable resources because they are continuously available or can be replaced in a relatively short period of time. The radiant energy from the sun is constantly created through nuclear fusion. As air masses move across the earth, temperatures change and produce wind. As long as the sun continues to burn in space, shining light and radiant energy on the planet, these two types of energy will be available. Energy from waterfalls and dams also is a type of renewable energy, one that is often converted into electrical energy. So if you think as well, like Gloucester put in the windmills a couple years ago, those are a form of renewable energy because as that, the wind is pushing the turbines of the windmill, which is then turning that kinetic energy from the wind into electrical energy that is stored in generators and batteries, which is then made into electrical energy that is sent to our homes. Now, as that electrical energy is being used by buildings and streetlights and homes, it is being renewed because the wind is pushing those turbines to continue creating or generating electrical energy. Windmills, hydraulic electrical stations, even something as simple as like a mill over a river, like a water wheel. Those are all forms of mechanical energy that is converted into electrical energy and renewable as long as that system is moving, as long as water is flowing, as long as the wind is blowing, that energy will be renewed as it's being used. Back on page 238, we have a purple box that says career. Roller coaster designer. Imagine getting to design the fastest, the tallest, and the most extreme roller coasters ever, with tunnels, complete inversions, and death-defying drops and speeds. Very few people have this opportunity. About 100 companies in the United States design and build roller coasters for amusement parks. A roller coaster design has a degree in mechanical, electrical, or drafting engineering. Usually, a team of several different engineers work together to design and assemble a roller coaster. Oftentimes, an amusement park will hire a company to build a roller coaster to fit in a certain space, carry a certain number of people, and have a specific design feature such as loops, drops, tunnels, or water. The designers have to create a roller coaster that meets all the criteria, is fun to ride, and is safe for passengers. When the roller coaster is complete, the designers get to test ride it for free, which is awesome, but I think also slightly terrifying because if someone made a slight mistake, then that could not end well. I saw a show once on Netflix, I think, I forget what the title of it was, but it was something about people building things in their yards that were extreme. And so this man in Germany, I'm pretty sure, built a roller coaster in his backyard. Not a large amusement park size one, but a good size roller coaster that sat a single person in a seat, and it was kind of like a luge. And he was able, it took a lot of trial and error to figure out the best way to do it, but was able to make a roller coaster that you could go all the way through from beginning to end. It had hills and some, turns, and was able to do it safely. But a lot of this, there's a lot of math to it to figure out, okay, if a person weighs this much, they're going to be going at this velocity. Is that going to be enough to keep them in their seat without them falling out of their seat around turns? So it was pretty fascinating to see the math that had to go behind and the engineering to create a roller coaster that would be safe and enjoyable in his own backyard. Pretty cool. All right. Back onto page 239. Other types of energy come from non-renewable resources that cannot be replaced once they are used, or can be replaced, but only over long periods of time. These are most chemical forms of energy such as coal, gasoline, and other petroleum products. Old Earth scientists believe that these products from organic matter over long periods of time and under intense pressure. Although God has placed great quantities of these resources on Earth, in the past 100 to 150 years, they have been used in large quantities. Scientists speculate as to how long these resources will last. So that's why you see a lot of places turning to more renewable energy sources and why there's such a big push on it right now. One, because of global warming, a lot of the energy that we use right now, or the energy sources, do create pollution. So gasoline in cars, oil used in your homes, diesel fuel, coal, gasoline, petroleum, all of these things do create toxins that are put into our atmosphere that they believe are causing negative effects on the earth. And the more we use, the more industry there is, the more cars there are, the more pollution there is. And it's not renewable. Once you burn coal or burn oil or use gasoline, it's not like you can renew it. And these are sources that are created over long periods of time, deep in the earth, from organic matter breaking down and turning into these products. And so it's not something that can easily be recreated. And so switching to more renewable energy sources like windmills or natural gas or hydrofusion, hydroelectrical plants, or solar panels. These are renewable energy sources because they're things that are collecting energy from events that take place every day: wind, water, sun. And so those things are going to last a lot longer and are actually better for the earth. They are more expensive up front, but they pay off in the long run. Let's see. Much of the industrialized society depends on non-renewable forms of energy, so energy conservation is a very important topic. Using public transportation, such as buses, subways, and trains, is more efficient than using a personal car. Also, the heating systems in most North American houses rely on petroleum products. Although one alternative is to use electric heat generated at a nuclear power station, these stations create radioactive waste, an environmental hazard. Wood is not a good alternative because forests take decades to renew, and the ash and carbon dioxide produced by burning wood contribute to air pollution. So even something as natural as burning wood isn't the best way for us to get energy. Electrical energy is needed for computers, lights, and hundreds of appliances, including washing machines, hair dryers, televisions, toasters, and microwaves. Waterfalls and dams provide a strong renewable resource for generating electricity. However, there are not enough waterfalls to supply a large quantity of electricity that is needed. This means that electricity must be generated in other ways, including by using nuclear power plants and by burning coal or natural gas, all of which are non-renewable. If you look on the other page, you have some oil production by region. And so you have millions of tons, or tonnes, and then years, and then you have the regions which produce the oil. So you have Asia Pacific, Africa, Middle East, Europe and Eurasia, South and Central America, and North America. So the largest oil industries are in the Middle East. You can see that by the orange band that goes through. And that's for oil production. They produce the oil, they extract it from the earth, and are sellers of oil. Now, if you look at the bottom to oil consumption by region, which regions use the most oil, you can see that Asia Pacific uses the most right now, but the U.S. is pretty close in following after in the amount that we use. And so there's a really big need for us to switch over to more renewable resources, because if we were to run out of oil or gas and we don't have any other sources, then we're not going to have a means of creating electricity needed or heating sources without that oil. So it's good to be thinking forward and moving in that direction. Try this. Conserving energy. Efficiency is a key to conserving energy. Design a pendulum system that uses string, weights, marbles, paper clips, dominoes, and a metric ruler to dump 20 grams of rice out of a paper cup and onto a container. The goal is to use just enough energy to get the job done. Use each of the supplies in the smallest amount possible. The energy must travel 100 centimeters and start with gravitational potential energy of the pendulum and finish with the rice pouring into the container. Illustrate and label the different forms of energy in your system. Write a summary of your process detailing how you conserved energy. List any additional materials used. Compare your system to other systems in class. Which system used the least amount of energy and which used the most? So if that's something you have materials for and want to give it a try, go ahead. I'd love to hear about it. More people in industries are turning to solar power and wind power to generate electricity. What deters increased use of these renewable energy resources? Changing requires large amounts of capital or monetary funding, which makes it cost prohibitive for many. Researchers and technicians continue to develop more cost-efficient technologies for harnessing solar and wind energy. Research and development often has high costs, but the future benefits make it worthwhile. So, for instance, in order to put solar panels on your house, it's pretty expensive up front to do that. I know there's Mass Energy has been doing, going around and doing not free solar panels, but allowing cheaper rates, or you pay over a longer period of time for your solar panels, so you're not having to pay up front because they see the benefits in having solar energy. But a lot of these things, if you were to put a windmill up in your yard, a smaller one, obviously not the size of the ones we have downtown, but you could run your property off of a small windmill like you would see on farms out in the Midwest. And so, but it takes money and capital to be able to build that before you are going to make money by saving on your electric bill. Now, the neat thing with solar panels or wind energy, if you have that, is over time, once you have paid off the cost of what it cost you to put up the solar panels or the windmill, you're actually going to create more energy than your house uses, and the electrical companies buy that back. So instead of paying your electric bill every month, sometimes you end up receiving a check from the electrical company because they're buying your extra electricity off of you. So pretty neat in the long run, and renewable and much more efficient for our greater communities. Questions for today. What is the law of conservation of energy? As a reminder, you might need to go back a few chapters to review what that definition is, and you can always look in the glossary in the back of your book as well. 2, identify the energy at different points in a roller coaster path and explain why each hill is smaller than the previous hill. So think about the relationship between kinetic energy, potential energy, mechanical energy, and how those relate to each other depending on where it is on the ride. If energy cannot be created or destroyed, explain how it can be wasted. Describe the differences between renewable and non-renewable energy sources and give an example of each. 5, why are most non-renewable and renewable energy sources used? And 6, list several ways to conserve energy in a home. So think about your own home and what would be some ways that you could conserve energy, or your parents could do updates to your house in order to conserve energy. Think about the way your house keeps in the heat, the way you use electricity throughout your home. I remember hearing an electrician come and teach in my class at one point, and he said that even leaving things plugged into the wall, even if they're off, are still using energy. Like if you leave your toaster plugged in or your hairdryer plugged in, it's using a small amount of energy as it's plugged in, even though it's not actually on. Oh man. So be thinking of ways in your own home. Okay. Be thinking of ways in your own home that you can conserve energy. All right. I will see you next time as we go on to power, machines, and force.